Welcome to the Data Exchange with Ben Lorica, presented by Gradient Flow.
Matt Honnibal, co-founder of Explosion AI. Welcome to the Data Exchange podcast.
Thank you. I'm glad to be here.
So I have a surprise
in my apartment, but virtually here.
I have an actual surprise for you. I'm going to start.
Oh yes.
I'm going to start the conversation by quoting your announcement blog post for Spacey. All right.
Okay.
So here's what you said then. To do great NLP, you have to know a little bit about linguistics, a lot about machine learning, and almost everything about the latest research. The people who fit this description seldom join small companies. I think a lot of that, what you said, still holds, right?
Well, it's interesting to think back on that and to think which bits hold and which don't. So I would say that one thing that's different is that the dissemination of knowledge from academia into a wider software ecosystem is much stronger now. So I remember when just before I launched Spacey, I had written a couple of blog posts that had done pretty well on social media, and I attributed that to not very many active academics actually, writing up a decent blog post explaining some techniques and things. And so I saw a real gap there, and there's still to some extent that gap, but these days there's many very high quality blog posts about recent results and about models and things. Which is actually one reason why I've been blogging less. I feel like there's actually a lot of stuff out there that's really good. So that's definitely one thing that's changed. These days, actually, the linguistic thing, it has a sort of different emphasis. I might have put that slightly differently, but I still think that that's true, that it's useful to think about it in those sorts of terms a little bit. So I'd say broadly, but, basically a little bit less than it used to be. And certainly there's more people graduating from PhDs now than there used to be, more people who graduating from masters and things. And so I do think that there's sort of a wider spread of people around than there used to be.
So deep learning has changed several fields. One of them is computer vision. So if you talk to the old-time computer vision people, they kind of lament that a lot of the youngsters don't need to know that much about computer vision, right? So they just use deep learning. And so actually a few months ago, Matt, I ran into he might have been a third or fourth year grad student in NLP in Berkeley. And he was lamenting that the first year grad students didn't even know some of the basic NLP stuff that people used to know, like TFIDS or whatever, right?
Sure.
So how much linguistics and NLP do people need to know these days?
So I think it's interesting. Like, on the one hand, you don't want to be, the old man yelling at clouds. Like the point of the field moving forward is that things should be easier now than they used to be. Otherwise, what's the point of the techniques? So it should be the case that it takes less accumulated knowledge to get some result, or less accumulated effort to get to some result. Otherwise, that would mean that we haven't made any progress in this time, which I don't think is the case, and I don't think we should want it to be the case. So it would be disappointing if we looked at our toolkit and we saw that actually we have to teach people the same things now that we're teaching people in 2002. We should want to be trimming some of these things from the curriculum. That said, there are some of these techniques that are actually practical because they have a different performance trade-off. But the problem is that you lose a bit of generality, and in particular, a lot of the sort of classic techniques that people would advocate for, like this TF-IDF stuff, which is basically just chopping up the documents and viewing it as like a bag of words. Those things work pretty acceptably on English, and they have pretty, compelling speed, accuracy trade-offs in a lot of tasks for English. They really don't generalize to many other languages at all. And so I think that one of the things that we've gotten from deep learning is a bit more generality there. So you know, I would say that the things where people should be thinking about language a little bit more, it's, I don't know whether I'd say thinking about it in terms of formal linguistics, but at least thinking about the problems a bit more. Really come down to when you're doing the annotation, when you're framing the problem. So one common sort of stumbling block that I see with people is very often people will want to do some new task, like, you know, they want to solve some problem that the business has with natural language processing, and they see, all right, well, I can, if the computer could identify these spans of text reliably, the way that I think of them, then I could feed that forward into another bit of the application and the business need to be served. So basically they want to have spans of text and have a model that can replicate those. Now the question is, when you go to annotate those spans of text, what do you annotate and what don't you annotate? Or how do you decompose the business problem into these tasks? So if you don't have any thinking about the linguistic sort of complexities behind it, you can really quickly end up with things where you're not annotating it in a way that's like consistent, or you're not annotating it in a way that will actually allow some generality. So having some sense of which bits you can carve off and say, okay, those bits don't interact so well and those bits do, will help a lot. So, you know, for sort of traditional named entity recognition, where you're annotating like a company name, one of the things that makes that work as a span classification is you don't tend to have much internal structure within it. So if you've got like Apple Technologies or Google or something like that, it works as a flat phrase. Whereas as soon as the internal structure matters a lot more, then this task of annotating it as a flat span doesn't work so well. So that's the type of thing where thinking a little bit more about the language can help you design the tasks, and that will help you deploy the technology in a way that actually solves problems better.
So you created Spacey right after grad school, and your focus in all your work, which now spans spaCy, Prodigy, and Thinc, has been on the developer. So obviously you got your PhD, so you were on the road to being an academic yourself. So when did you start really becoming interested in the developer?
Yeah, it's been an interesting sort of road, because especially since I started my academic career as really the linguist who was starting to dabble in computer science. And my role within the research group when I started out as a PhD student, I really saw myself as having that as the comparative advantage. Like I was like, okay, I'm bringing like, you know, this deeper connection to the linguistics to the table, and I always felt a little bit inferior as a programmer. And, you know, I didn't have serious programming skills like these people who had studied it. So it was interesting to make that transition. And I guess after I finished my PhD, I spent a few more years, like, you know, working in research groups. I was, you know, basically a postdoc. And that was kind of nice. But the thing about academia that I realized is it's about 3 or 4 different jobs mixed together. And I liked some of those jobs and not others. So I basically left at the point where I would have been writing grant proposals. And, you know, the aspect of interacting with the university administration, I didn't particularly love. I was kind of disillusioned about teaching. I felt like, you know, a lot of the teaching that I had experienced was in master's programs in Australia. And in Australia, education's a big export industry. And I think that the way that the university structured those programs is pretty cynical, and I didn't feel like I was doing something very, you know, ennobling that made up for some of the other compromises that you had with life as an academic. And so I felt like there was this other thing that I was gaining interest in, and it was, you know, felt like I was increasingly confident at, and so I decided to try my hand at that instead.
Yeah, I mean, I can definitely relate, having spent 5 years after my PhD in academia on the whole grant proposal thing. Not my bag of tea either. So let's go through each of your projects in detail. So spaCy, what's new? What's upcoming? And how is the community?
So in terms of what's new, the way that I've been thinking about this is if we look back at the history of the project and what's changed in the meantime, when we first sort of launched spaCy and when I was first designing it, the developers who were using it were a little bit different because, you know, there was much less sort of knowledge of these techniques and the general sort of attitude of people with that they wanted, really the one technology that just worked, and there was much less appetite for, say, training models or plugging in different models and things. Now, as deep learning has developed and the user base of these technologies has shifted, that's kind of no longer the case so much. And in particular, deep learning gives this interesting trade-off where, in order to make use of it optimally, you really want to be interacting with the models, because then you can that's the point at which you compose a lot of solutions, and you say, I can, say, do some image task if I feed in the image as a vector here and then combine it with the text vector there, and I'll put them together, and then maybe I'll output one set of labels here and they'll be mutually exclusive, and these other labels will be non-mutually exclusive, or something like this. And that's the level at which people want to be working with these technologies. And so we sorted, there was a bit of a challenge for Spacey there, where we weren't offering that level of detail, because part of the task of designing a library like this is deciding what level of abstraction people will want to work at. And so the level of abstraction that people want to work at has changed a little bit, and so we see a need for changing that. Obviously, another thing that's changed is GPUs are much more popular as an execution platform and a training platform. And also the other ecosystems around the library have developed as well. So for V3, the big change is having a much better configurability of the model and the ability to bring your own model and plug it into the Spacey pipeline. So we're really pleased with the way that the configuration and training system is coming together there. We're also I'm also working with the team from Ray to bring distributed and parallel training and make much better use of GPU resources. So that's another thing that I'm really looking forward to as well. And then also, lots of fixes and improvements. Fortunately, I think we won't actually have to do much backwards incompatibilities. We like to make sure that that's something where we have some stability for people. Really, the only changes that I really expect are around the training workflows, because we should be improving those pretty substantially.
By the way, when Spacey came out, just for the listeners who aren't following this closely, I think the libraries that I was using at the time were Stanford NLP and NLTK, and then Spacey came out, fit perfectly with someone who used Python, but then was super fast, right? So I laud you for kind of embracing Python, and of course now Python is everywhere, right? So yeah. So what about Prodigy? So tell our listeners about Prodigy.
So Prodigy is an annotation tool that we developed in Explosion AI, and it's our main commercial product. It's how we make money and support Spacey, and it's actually been pretty successful, and we've been able to fund the growing team this way. So the next release of Prodigy that Ines has been working on, it comes with support for relation classification tasks. So these are tasks where basically you're trying to link up pieces of a sentence and basically draw arcs over them. So this is a type of task which we really people have been asking for a lot, and was one of the main missing features from Prodigy. There's also a big support for audio that's coming in. So we've had a researcher in France who's been working on this a lot, and we're pretty excited to see what people do with that. There's improved image support, and I think the other thing that's coming soon in like a 2.3 release is a lot of new language models. So we've got new support for Chinese, Japanese, and lots of other languages, and so Prodigy also will have good support for those and doing annotations in those things. So we're pretty excited for all of those features as well.
So Matt, a couple of questions. So first, I guess I did not realize that Prodigy has gone beyond text to support audio and images. And so for our listeners who aren't that familiar with this space, so why are companies paying for a data labeling tool?
Yeah, so the thing that sets Prodigy apart a little bit compared to many of the other tools is that it's fully scriptable, and it really gives you this experience of being able to write a quick function. You just need to have a generator that queues up the examples, and then you'll get a command line interface, and then it can put a web app on the screen. And so it coordinates the server back command line interface and database for you, so that you can basically just have a really quick way to visually annotate some examples. So a lot of developers love this as an extra piece of their workflow. Basically, it allows them to really easily get that better connection to the data, and even just doing things like a little bit of error analysis, or annotating some model like a similarity model or translation where you need some manual judgment for them. And of course, just annotating some data for a prototype. So what a lot of people are finding is that, very often, to do any new project or to have some new idea as a data scientist, you need to annotate some data. And the alternative to this, to doing it yourself or to doing it at a small scale, is that you have to call a meeting and argue for some budget to do it with a third-party service or something. And by the time you've done that, well, you could have just done it yourself. And then you're able to show those prototypes much quicker and get, sort of know whether something's working. And then teams are also using it for, the sort of medium scale deployments where they, have it as an ongoing thing to train models where they've already passed the prototype stage. So compared to the free tools, people are finding that it has these extra features, and it's, that little bit more polished, and gives you that, basically higher annotation rate. And then the other thing that people really like is that it's fully downloadable. So you pay once for the license and you get it and you can host it yourself. You don't have any data privacy concerns or any, lock-in concerns to that, because you can always just export the data from the tool and use it however you want.
So there's a group out of Stanford that they're the proponents of something called weak supervision. So they've had a couple of tools. One was Deep Dive and now Snorkel. So I think one of the personas that they target is a domain expert who does the data labeling by through a UI, but also by writing these small scripts. But then it gets plugged into the entire pipeline somehow, right? All the way to training the model. So is Prodigy kind of similar in that sense? You also provide a mechanism for a non-programmer to use it. So
the Snorkel works definitely really cool, and we've been looking at that as well. It solves similar problems in a slightly different way. So we allow you to have a model in the loop so that you can have some sort of rule-assisted example selection, or use a model for the example selection. And you could actually implement some of the ideas that Snorkel have for their weak supervision as well. I would say that in comparison between the ideas, I guess Prodigy is also a little bit more direct. You don't have to use these approaches. You can just put some examples on the screen and annotate them. So it has a bit more flexibility in that way, and it's not built around as much of a central idea as the weak supervision idea in Snorkel is. The other thing is that these days, with modern transfer learning, it's not necessarily the case that you need a huge quantity of annotated data, and so the task of basically having this weak supervision thing to gather a massive training set isn't always necessary for some language tasks, which is another sort of comparison between them. But I do think that Snorkel's definitely has a lot of cool ideas, and we've been looking at it as well, and we want to see if there's something that we want to take as inspiration from it.
So Matt, before we move on to Thinc, what are the key industries where you're seeing a lot of adoption for Prodigy?
So we're actually quite spread across a number of industries, and that's one of the nice things about having it. Through we get a connection to people through our open source work in Spacey. So there's actually quite a wide base of people who sort of see this and figure out whether it's useful or not. So we don't, if you have a sales strategy where basically you try to find customers who are similar to your existing customers, you end up with kind of this focused on a narrow vertical, which fortunately we haven't had to have, and so we've got people spread quite widely. I would say that we've got a number of people using it from finance, and adjacent industries like professional services or assurance and that sort of thing, auditing. Then we've got a number of users in the pharmaceutical industry. We've got some companies that are just sort of more pure tech, and either brands that you've heard of or like ones which are just sort of these. There are many small to medium tech companies that basically are out there as well. So yeah, I'd say it's a mix. But if I had to pick the two or three largest, I would say would probably be finance, pharmaceutical, and then also a couple of these engineering companies and things. We've got some users across those.
So let's move on to your latest open source project, Thinc. So what is the origin story of Thinc, and tell our listeners what is Thinc? What is the problem Thinc is trying to solve? So
we've actually had a library called Thinc for since as long as Spacey has been around, because the first versions of Spacey launched with these fast linear models, which was a pretty common way that people did NLP at the time, and it was also pretty common at the time that everybody would write their own versions of these things, because you'd have to write it in a low-level language like C, and then it was kind of hard to make interfaces in C that are both like well optimized and very general because of the lack of generics and things. So given that the algorithm was pretty simple, it's like others, I had written my own implementations of these things. That was in this library called Thinc. Then as sort of time passed and Spacey moved on to deep learning models, there was the decision of whether we should basically stop and adopt a library like PyTorch. So by the time that PyTorch was released, I'd already been working on deep learning models within Thinc to get Spacey up to date with those things. And the decision at the time was that people were using a range of libraries, including TensorFlow, PyTorch, MXNet, and things. And also these libraries were all moving pretty fast. So our concern was...
Matt, among developers, Keras, right?
Well, yes. So actually, I count Keras as TensorFlow these days, but it was a different library at the time. The idea was, all right, if we make Spacey depend on, say, a particular version of PyTorch, then this can just cause problems for people, because if they want to use TensorFlow as well, it's difficult to be using the two at the same time. If PyTorch moves quicker than we can move, then people will have a version conflict, and all of these things can basically cause trouble. So we decided that, all right, we'll stick with our approach of just implementing the functions that we need in our machine learning library. We never documented it because we never wanted to suggest it to other people as like, a sort of alternative. We were like, we're just serving our own use case with this. So then as time went on, PyTorch got more stable, and we were thinking, all right, should we revisit this? But what we saw was, there were some things that we liked about the way that we had done the models, and we did like not having a dependency on the other things. But we actually saw that there was these technologies for basically integrating to PyTorch and to TensorFlow pretty closely. So there's this DLPack standard where you can have zero copy transfer of arrays in and out of these models. And we found a design for Thinc that works really well as a wrapper library as well as its own standalone thing. So you can basically use it as a sort of container where you can plug, say, some PyTorch model that you want to use and use that directly in Spacey by just using Thinc as a common API. So Thinc will be able to interact with Spacey, and Spacey will expect this common API from Thinc, and then under the hood you can have MXNet, TensorFlow, or PyTorch as your models internally. And indeed, a lot of companies actually have internal frameworks that they've used to sort of sit there, meet their own needs, and then so we thought it would be good if we allowed people to have a full choice of machine learning solutions. And then there were also some things that we liked to do as well, sort of taking some sort of a fresh look at the problem. We were able to have really first-class support for typing, including type support for array types. So you can get type errors if you see that there's some operation that is illegal, and it can say, that slice that you're taking there is only 2 dimensions, and you've got a 3-dimensional index there, and so I can see that there must be a bug. So that's something that we think is pretty cool as well.
So let's kind of unpack this a little bit for developers. So I'm a developer. I know nothing. I know very little. Let's say I know very little about NLP and language. I just want to use libraries. And I've been reading, and I keep reading about this humongous deep learning libraries. Now GPT-3 has 175 billion parameters. But then there's these tools like so one of the popular ones is Hugging Face, right? So where they pre-train these models. You're a developer, you just take advantage of Hugging Face. So why do I have to care about Thinc, TensorFlow, PyTorch? Let's unpack this for developers. So I'm a developer. I know nothing or very little about NLP, but I keep hearing about these cool natural language models that are humongous. So the latest one from OpenAI, GPT-3, has 175 billion parameters. There's no way I will train these models myself, right? So then I hear about tools like Hugging Face, where the benefits of these models are exposed. So I can just call Hugging Face using their API, which is pretty simple. So why do I need to care about deep learning at all, or Thinc, or TensorFlow, or PyTorch? So explain the landscape of the tools for a developer who just wants to use NLP.
Sure. So always in any project, you can think of it from a very high level as, basically getting computers to do your bidding. There's this thing where, you have like a want, and you want to express that thing so that the computer, you set your program does the thing that you want it to do. So always there has to be some sort of control mechanism where you're inputting your desires. You're making it your program as opposed to, just a program that somebody else gives you. And in traditional programming, you do this by, basically writing out the logic explicitly, and you get a nice syntax for it, and you basically just code out the rules of how the logic will flow. In machine learning projects, you get an option of a different way to express your desires. Instead of having the ability to write in just like the Boolean logic that you want, you can give it examples. Will give it input-output example pairs, and it can learn to replicate those. And so you can have some subunit of your of your program's logic that you've programmed in this different way. Now, so you can see here that it's always going to be something where you have to interact with it in some way, and you have to interact. There's 2 points of that interaction. One is you probably want to give it some examples and have it learn something so that it's doing a thing that you want it to do, not something that, it just sort of comes as default that somebody else gave you. The other one is that you need to take its output and do things with it and put that forward into the rest of your program. There has to be some point at which you're actually using the output. Early in the deep learning thing, people talked about fully differentiable programming, and, everything will be a vector. Well, at the end of it, you need to have some sort of, categorical result in order to use in the rest of your program. Because, you can't just put a vector on a screen and say, here is your answer. So there's always going to be this thing where you have to decide, okay, how am I going to use these technologies? So let's imagine that what you need to do is, let's say you're working with reviews, and you say, all right, I want to understand what aspects of these products that I'm interested in people are rating highly or poorly, so that I can come up with some sort of summary. I can classify the reviews and focus in on the ones which the messages within them that are actually going to matter for us. And so I can have some sort of voice of the customer model that's crawling the internet and understanding whether, people are liking the, power drills that we're putting out into the world. And so you want to, read lots of forum posts and see what people think. So if you just sort of download some, model like GPT-3, there's not going to be a button that says crawl web to find reviews of power drills and like find out what people are saying about them. Instead, what it will do is give you, real strong baseline of language knowledge where you only need to give it a few examples in order to have it learn the task. It's like taking on a new employee, and instead of having to teach them English, you just have to tell them what sort of things about these reviews you're interested in. But you still have to tell them some things. There still has to be some sort of way that you're specifying what you want. And so the Hugging Face Transformers library is very useful, and in particular, it's great how quickly it stays up to date with new models and how
instant, right?
Yeah, really. So it's not always the best to be using the most bleeding edge model that people have put out, but it's great to be able to try them, and it's great that they're all sort of there, and you can really kind of rely on that. So we're redoing the integration of the Transformers library with Spacey for V3. We learned a lot through the first version of it, and I think actually we're pretty excited by the results that we're getting. Using transformer models to train the pipeline, we get results that are really close to the current state of the art of the various tasks that we're doing. But you do still need some way of training these models, composing rules together with them, using the outputs together, and that's where we see Spacey has some advantages over other libraries, in particular over the doc object that we have. I think that it's the best way to look at multiple types of annotation together. So you can say, all right, find these entities and then relate them to some text classification label, and then relate that back to some relations between the things. And that's something that Spacey has always been pretty good at.
So the average developer who doesn't follow NLP closely, how should they think about all these things that they're reading? Because it appears to the people on the outside that things are changing fast. So I guess one of the things that you mentioned is, I guess, being able to experiment with some of these models, maybe not necessarily use them in production, but set up a workflow or a workbench where you can try new things, right?
Mm-hmm. So I would say that things have actually been changing a little bit slower over the last 12 months than the 12 months previously. Things are kind of settled into a bit of an equilibrium, and there's been incremental advances on a lot of these tasks. Certainly some of the models are getting larger, but actually if you look at the sort of price performance point, the trade-off is getting better and better. So for the same level of performance that you want to get, say, from 2 years ago, that's a lot. You can get that a lot faster now. So while there's really big models that are coming out, the horizon of what will fit within some application needs is continuing to advance at the same time as the hardware is getting faster. So I would say that a good way to start would be the Fast AI course. That's and you don't have to necessarily do the whole course, but it's sort of a good overview in these things. I would say that's probably, it's better to understand a little bit more about how things fit together and what's going on. If you just try to use the APIs directly, especially the bigger models, because they run on these GPUs, it can be a little bit frustrating because there's sort of a lot of waiting, or then it's expensive to use if you don't have the machine locally. I would say it's probably better to basically understand a little bit more about how things fit together, and then what you'll find is that the actual code for the program is pretty short because you are working at a reasonably high level of abstraction.
So before we started recording this podcast, I invited you to speak at the Ray Summit because I'm the co-chair of the Ray Summit. And you mentioned that you folks are beginning to use Ray. And I guess with these language models becoming bigger and bigger, it does seem like Ion Stoica, one of the founders of Anyscale, wrote a post, the future of computing is distributed. It seems like that is going to be the case, particularly in natural language. So tell me about what's your sense of distributed computing moving forward in NLP?
So there's a couple of dimensions in this. One is just, the mechanics of how quick it is to get a model trained, and, that when or even whether it's feasible to train some model at a certain size or whatever. I think that one of the really big impacts that people underrate a little bit is workflow. I think that if you're not using distributed computing and you're doing this sort of data science work, you're really trapped on your one machine, and you're doing things in series. So you have some idea, you hack a little bit, you wait a while, you stop the experiment before it's even, basically at an arbitrary point, so you're never quite sure. And you're basically sort of going in this hacking and tinkering sort of space. You're not planning out like a slate of experiments and working sort of rigorously towards that. So, and you're not, it's kind of like, pushing code directly to production instead of using a CI. You're also not like you're probably not logging your experiments as like rigorously as you could. And this means that you're kind of trapped at, what they call this grad student descent sort of phase, where it's very time consuming and takes, and the results are kind of unpredictable as well. Whereas if you're able to execute the jobs remotely, you're abstracted from the machines. And so if you've got, say, 20 experiments to run, it's not actually necessarily cheaper to run them all on the one machine and one after the other. If you at least have access to cloud resources, then you can run them all at the same time and get the results and then keep working. So I think that the workflow advantages of having access to, basically an abstraction point in between you and the machine rather than just running it locally can be very strong. The only catch is that the tooling has to be good enough. And I do think that Ray is achieving that, and the cluster management is pretty good. But it's the similar sort of logic that, people had with Spark, where, it's good to be able to run things sort of reliably remotely. And I think that that's a big difference that is sort of there to be gained. And, the Python ecosystem has never quite settled on a solution for this yet. I've used Dask, and it's a good technology, but there's, also some things where I feel like Ray has some improvements there, and it's also got a very consistent and small API too.
Right. So you've led a few open source projects. So Spacey being the most popular, and then now you have Thinc, which is getting started. So this is a question I ask people who are leading open source projects. So what metrics do you track? So I think that most open source project leaders in the beginning, they get obsessed over GitHub stars, but they quickly realize that that's not the right metric. So Matt, you're in an unusual position because you have a much more mature project, Spacey, and then one that's starting out, Thinc. So what are the lessons from growing Spacey that you're going to try to apply with Thinc?
So actually, I think one of the things that's interesting from our position in Explosion is we're much less metric driven than many people would guess, being a company in the data space. We basically believe in making decisions on, our logic around what we think is going to be good. And I think that it's very easy to mislead yourself with data. So, if we looked at our website stats or something and we saw the website, our visitors to the website dropped recently. Well, that, it's very difficult to actually figure out what that implies. And the process that you should do to actually get an accurate conclusion on that would be 99% reasoning anyway. And if you tried to be too data driven about it and tried not to be driven by what you actually believe about, how things are working, then you would easily mislead yourself, because the data is very uninformative. It's a very thin flicker of information compared to, and it's not actually an easy way to distinguish any theories. So we do look at GitHub stars, but we're very careful not to optimize for them, because you would destroy any signal that you had there. So as soon as you did anything which where you think that you're influencing that directly, even, should we post this as an announcement that links directly to the repo, or should we post it as a blog post or something? Well, if you're thinking if we do that, we'll get stars versus not stars, then you're already destroying any value in that signal. So fortunately, one of the advantages that we had from not taking outside investment is we don't have to be trained to any of these things, and we don't have basically a direct thing where we're like, well, if our numbers, we've chosen these as our metrics and we've taken responsibility for improving them, even if we don't think it's important for the business, because if we don't show the investors that we're improving in our stated goals, then we look out of control. That's not a problem that we have because we don't have outside investors. So, I think we look at hits to the website, we look at I guess sometimes we look at the download stats, but those are very influenced by other factors as well. And we look at GitHub stars as well. But then we also just look at, basically satisfaction. We look at, is the library getting better? Do we feel like we're able to stay on top of the issues that are coming in? Do we understand what all of those issues are? Basically, are we able to keep, if we release something and make a promise to maintain it and to keep it stable, are we able to fulfill that promise, or are we falling behind? Those are the metrics that we see as most important.
And obviously, you interact with the community, right? So you can see what people are reading in terms of the documentation, and you probably answer questions on Slack or other platforms. So there's other ways for you to get a pulse for what the community is having problems with and asking. Right?
Yeah, and it's interesting as well because the sample is so skewed in any of those fora, right? Because some people will be 5 to 10 times more likely to ask questions than others, and certain user categories and certain attitudes of users and things are more likely to generate questions. And so you have to have a bit of a filter for that as well. And there's some people that we start interacting with in the community, and then we see okay, that's somebody who's, basically judgment's more reliable, or it's a type of user that we see that they're, maybe they've sincerely tried to do something and they're reporting problems, and we're like, yes, plainly there must be that there is an underlying problem there. But then there's other people who, their instinct is to ask on GitHub instead of reading the docs, and then we're like, well, we don't necessarily see that as much of a, useful feedback source or something.
So actually, the other thing that's interesting about Spacey is that it has a strong following among developers, but also among researchers, right? So the research community also uses Spacey.
Yeah, I think it's interesting that way. And actually, we're really pleased to be serving researchers who are sort of outside or adjacent to computer science as well. So people who basically want to use NLP in their research. We've got a strong user base there, and we've been very pleased to be helping them with that. I think that for the people who are using, who are working directly on NLP, so we have people who are using it to, they just need a named entity recognizer, they just need a parser, or they need a pos tag or something. Then they might choose to use Spacey in the same way that they used to use, say, Core NLP, or other ones who still use Core NLP. It's a fine, still a fine library. So I think that that's the kind of use case where people in researchers would, basically be in the same position as a developer of well, I just want a reliable tool that sort of does a job within this project. Spacey isn't well set up to do something like researching, building new named entity recognition models. For that sort of thing, people really want to be owning their own code and, working directly in with fewer layers of abstraction and that sort of thing. And so for those types of use cases, it makes much more sense for people to, maybe they use a tokenizer, but otherwise they would basically just be writing their models directly.
By the way, when you released Spacey in early 2015, obviously Python has always been popular among the data science community, but at that point, I mean, it was unclear that Python would dominate the way it is now. I mean, JVM technologies like Spark and whatever were still very much in the mix. But now, with deep learning especially, Python seems to be the language for ML, right?
Yeah, so I think it's interesting. One way to look at the decision to do Python as the language for spaCy was actually related to it being an underdog at the time as well, because there was a gap there, and I saw that it was gaining in popularity, and the mix of technologies people tended to have were either in NLP, I saw people would either use Java plus Perl or they would use C++ plus Python, and I felt like for a couple of reasons the Python way was gaining ground, and one of the things about it is that you can gain much more close connection to the C and C++ ecosystem, and much more close connection to memory managed code. So and there it can start to matter a little bit. The indirection that you have in programming in Java can start to hurt you, and I think that's the way that's basically unrolled for deep learning. Like as soon as you're doing really high performance computing, the overheads from JVM start to add up a little bit more. The irony is that Python can also be quite awkward, and you are exposed to a lot of incidental complexity and incidental problems that come from the having to manage the performance these ways. So there's some things where I find myself scratching my head at the NumPy API, trying to figure out how to get through this like dumb basic loop that if I didn't have to worry about CPU, GPU computation, I would just do it immediately in Python, and it's just like a few things. But if I loop over to array this way, without if I just did that in pure Python, it would be way too slow. So there's some things where you have these sub problems of figuring out how to do something via a library, where otherwise in Java you would just be able to write the code directly.
So in that regard, does Ray help a little bit? Because Ray is starting to have an ecosystem of libraries and integrate with Python libraries, but allows you to run those libraries much faster even on your laptop, right?
Well, actually, I don't think distributed computing can solve this sort of problem, because these sorts of challenges come in where if your program fundamentally is, say, 20 times slower than it should be, then saying, okay, I'll just make it distributed is a really bad solution, because the distributed solution comes with all these overheads, it comes with all the costs and stuff. And so it's vastly preferable to just have it run 20 times faster. And there's a huge range of these things where, yes, it will just be 20 times faster if you just did it properly with worrying about say data continuity and stuff. Data size is also a huge factor with this. If the problem fundamentally is that your data is not contiguous in memory and that you're stored inefficiently, then you cannot solve that problem by going distributed. In fact, distributed will just make things worse, because now you've got a greater overhead with copying your data around. So, you can easily have some situation where you've got some big JSON structure, and if you just pack it down into the least number of bits, it will be 50 times smaller, and then your problem will be really trivial. Whereas if you just leave it in these inefficient formats and try to traverse them and stuff, then no distributed computing will really solve your problems.
So in closing, Matt, so are there other things you're following closely? I'm personally interested in potential applications of reinforcement learning to more regular problems. So are there anything along those lines that you are following that you're not personally involved with?
So I'm sort of deliberately sleeping on reinforcement learning while I'm, basically waiting for, it to be more directly applicable. It's actually a little bit disappointing how pragmatic I have to be, because I'm short on time for these things. So, I'm trying to stay, I call it about 1 year behind the research, so I can wait to see which, stuff has been more important, so that I can only read basically a smaller section of stuff.
You should use a machine to read for you.
Well, I mean, yeah, but then what would it tell me? Because then I still have to listen to its output, which is probably going to be. So instead, the machine that I have is the distributed intelligence of the research community. So I, instead of having to guess which stuff will be significant, I just wait for it to be significant, and then I can read it then. So Otherwise, I'd say that that's basically the sort of stuff that, I was looking into Jax a little bit. I think that that's kind of cool.
That's interesting. Yeah.
Yeah. But otherwise, that's, I'm.
By the way,
mostly just got my head down a little bit.
One more closing thought, since you brought it up. I actually admire what you folks are doing in the sense that you didn't take outside funding. You're kind of growing by growing your revenue. So, is there any parting words you would like to say to developers who are wanting to start their own thing, and basically encourage them that there's more than one model for starting your own thing, right? Yeah.
Well, so I really hate giving advice because I feel like the basis for it is really thin, and
Right.
I think that you basically have to be, the sort of glib version that Ines and I say is that, like, it comes down to being, right a bunch of times in a row, and there's not really any generalized like advice for that, and it takes a bit of luck as well.
Right.
And that means that, like, at the end of that, you can look back and say, like, oh, well, things went pretty well, or you can say, well, things went poorly, and I don't know that there's an easy way to.
But I guess the main lesson is there's more than one way to.
But that also doesn't generalize, because
right.
Look, honestly, I had a small inheritance when I started, which meant that, like, I was able to fund about a year of myself. I was I didn't have any dependents. I was in good health. I had a safety net of, like, my family didn't need me to, like, be stepping up and maximizing to give them stability,
right.
but also, like, could actually give me stability, so that I knew that, like, if worst comes to worst, I would be okay. So, I don't think that, like,
that's true.
I could give the generalized advice to somebody that there's more than one way, because I have no idea what position somebody's in, and also I have no idea what the type of project and product they want to do. So there are projects where there is a natural monopoly to it, and then you basically the logic of taking funding changes a lot, and so I think that we, as much as we try to there's Ines has given a talk at EuroPython where she explains our business philosophy and the way that we've put things together, and I think we're pleased to talk about these things and be a little bit transparent about the way that we think about this, but we don't pretend that this is a template that works for other situations or whatever. I don't know.
Actually, I respect that. Actually, that you're comfortable saying, I mean, every person has to find their own way in some ways, right? So,
yeah, pretty much.
Yeah. Thank you, Matt Honnibal.
Okay, well, thank you. This has been a pleasure.